University of Calcutta has a long tradition of teaching and research in atmospheric sciences. Till date, it has been using passive experiments to study the lower atmosphere. The Stratosphere Troposphere or ST radar has proved to be a useful and versatile tool for lower atmospheric and ionospheric studies. Appreciating that the lower atmosphere is the seat of many interesting physical phenomena with implications to global change, in 2009, the University of Calcutta proposed to acquire a ST radar under the DST program of developing ST radar network in the country. This was also in line with the existing research programs on atmospheric sciences operational at the university. The ST radars provide information on atmospheric parameters in the troposphere and lower stratosphere over a wide range of spatial scales. The three-component wind measurements provide information about wave disturbances, spectral width measurements contain information on microscale turbulence, reflectivity measurements contain information on small-scale turbulence as well as large-scale temperature gradients associated with tropopause. The most important and unique capability of the ST radars is the measurement of the vertical wind component with a high degree of temporal and altitude resolutions for studying atmospheric turbulence, which is very important information for aviation safety, space shuttle, and missile launch. This unique capability gives the ST radars an enormous advantage over the conventional wind measurement techniques using radiosondes.
The radar facility, which is recently functional at Ionosphere Field Station Horingata of the University of Calcutta, is a unique one at around frequencies of 53 MHz. This is the only such radar in an Indian university system and overall the third one in India, the other two being at ISRO laboratories. So, along with the pride, there also comes the challenge of proper scientific utilization of this major national facility. Towards that end, it is of importance to note that there are several departments within University of Calcutta, the nodal department being radio physics and electronics, and along with that, we have the departments of applied mathematics, statistics, atmospheric science, statistics, and environmental science who are collaborating together in order to have a proper scientific utilization of this major radar facility. There have been collaborations also with the National Atmospheric Research Laboratory of the Department of Space, Government of India, and Vikram Sarabhai Space Center under the Department of Space, Government of India. In addition to the normal lower atmosphere, mesosphere, and ionospheric observations, Indian Institute of Technology, Indore, they have a research group which is also trying to utilize this particular radar for passive mode radar astronomy. This will be an unique opportunity for them to study these astronomical features at low frequencies around 50 MHz.
University of Calcutta has established a fully active phased array Stratosphere Troposphere radar at Ionosphere Field Station, Horingata, with the financial support of the Science and Engineering Research Board. The ST radar at Horingata is a 950 kW high-power distributed complex radar system. It has 475 transmitter-receiver modules spread over 7,000 square meter area, having 25 digital receivers. This is a major research facility in eastern and northeastern India, as well as Southeast Asia. Presently, there are no VHF radars operational in the transition region from the tropical to subtropical locations in the Southeast Asian longitude sector covering India. Notably, this is the first 50 MHz active phased array radar in an Indian university set up and the first radar in India to have provision of remote access. In the troposphere mode, it is designed to give vertical profile of wind velocity up to 12 km and up to 25 km in stratosphere mode. The radar is operational and transmits 5 beams having a maximum off-zenith angle of 40 degrees, which can cover full azimuth range of 0 to 360 degrees at 1 degree interval, thereby providing option for wide-angle atmospheric scanning. Usually, all the 25 subarray signals are combined into one for Doppler beam swinging mode of observation to determine the wind vectors. In DBS, the entire antenna array will act as transmitter and receiver. In spaced antenna mode, the entire array is divided into 25 subarrays, each one of them will act as a transmitter and receiver independently.
Today, I am extremely happy to be here at Haringhatta. The University of Calcutta has established a state-of-the-art 53 MHz high-power large aperture atmospheric radar for carrying out research in atmosphere, ionosphere, and a broad field of space physics. Calcutta University has the heritage, a strong heritage in the field of ionospheric research, which was laid by none other than Professor S.K. Mitra. Now the same Haringhatta is a place of attraction because now it houses the most sophisticated state-of-the-art 53 MHz radar, which has multiple receiver capability to carry out the frontline research in the field of atmosphere, ionosphere, and space weather research.
This radar provides 3 components of wind speed, and direction with high spatial and temporal resolution up to a height of 24 kilometers in the troposphere stratosphere region, echoes from the mesosphere at heights of about 70 to 75 kilometers, and ionospheric backscattered signal from irregularities at heights of 1,000 kilometers. The location of this radar is unique, being situated near the northern Bay of Bengal, which is in the deep convection region, and also experiences pre-monsoon thunderstorms and tropical cyclones frequently. Towards that end, the high-resolution data from this radar could be very useful for forecasting such severe weather conditions. This radar has also been instrumental in the first tracking of the super cyclone Amphan, which devastated the eastern coast of India adjoining northern Bay of Bengal in May 2020. One of the major societal benefits of this radar facility is in the domain of disaster management. During thunderstorms and other disastrous short-term and medium-scale events like severe tropical cyclones like Ayla, Fani, Amphan, many huts were destroyed along with deaths of people and animals in the neighborhood of Sundarban. So, the ST radar at Haringhatta can have a great impact to the improvement of social status of poor people living in coastal area like Sundarban. The region extending from the Chotanagpur Plateau to the Bay of Bengal also experiences the highest number of lightning strikes globally, which causes the highest number of deaths from lightning. This radar facility, when augmented with an electric field mill, could make measurements of lightning strikes. Air quality is largely affected by burning biomass, which refers to the burning of living or dead vegetation including grassland, forest, agricultural waste, and burning of biomass for fuel. The wind measurement by the ST radar could be effectively utilized for understanding the aerosol movement, thereby helping to generate pollutant map over a certain region. This radar is capable of measuring signals reflected back from heights of up to 1,000 kilometers, wherein the effects of huge solar coronal mass ejections could be detected. These events are associated with huge currents of the order of millions of amperes, even a small fraction of which is sufficient to completely trip and burn the existing power lines. In addition, passengers flying on commercial aircrafts are subject to several orders of higher magnitude radiation, which could be fatal. During these events, all satellite-based systems and services including banking sector are severely affected, thereby inconveniencing a large section of the society. The advantage of developing this facility in University of Calcutta is accessibility to allied departments and amalgamation with related subjects like atmospheric science, applied mathematics, information technology, statistics, computer science, and electronics and communication engineering. The data procured from the ST radar at Calcutta University will be open to all scientific community in India.
So this is the radar which we are going to give to the user scientist community for observing the atmosphere and seeing the atmosphere with the very high spatial and temporal resolutions. where that was something which is difficult for doing it, in seeing the fast changing the atmosphere if we want to observe it. That is what we are adapted a multi-channel receiver system also in this radar, so that people will get the information or the parameters to be observed within the very high resolution, probably that less than 30 seconds of time. So whereas the other radars normally takes 3 to 4 minutes, this radar can do that same observations within the 30 seconds. This is the uniqueness of this experiment, and that leads to study very fast changing like a convective system, thunderstorms and all these things, a very better way compared to all other systems.
After the radar was commissioned in November 2022, University of Calcutta has formed a consortium of different departments interested in working with this radar and other associated instrumentation, so as to develop an interdisciplinary research initiative utilizing this major national facility. To achieve that end, the departments of radiophysics and electronics, atmospheric science, applied mathematics, statistics, information technology, and environmental science are involved with this major research facility to carry out research on different aspects using the radar. One of the major themes of research is to explore a threshold indicator of severe weather, including cyclonic activity, nor'westers, lightning, and air quality characterization with mathematical, statistical modeling and machine learning approach.